Welcome to the explainer. Okay, let's just dive right in. We've all seen it, right? You ask an AI something and bam! It spits out a poem, a story, a perfectly worded email, all in seconds. It really does feel like magic. But what's actually happening? Today, we're going to pull back that curtain and take a real look inside the machine.
I mean, have you ever had that moment? You're chatting with an AI, and you just have to stop and think, what is actually going on inside the computer right now? It's a great question. And in the next few minutes, we're going to uncover the secret behind that conversation.
And this is why it's so compelling, isn't it? That feeling of being understood is what makes the whole thing so wild. But here's the twist. That feeling isn't created by a thinking mind, not in the way we think of one. It's actually the result of an incredibly clever and, surprisingly simple process.
So here's the first big secret. At its heart, an AI that writes, what we call a large language model or LLM, it isn't thinking about what you asked. It's doing one single task over and over and over again. It's just predicting the next word.
That's the fancy definition. But really, just think of it like the most souped-up predictive text on your phone you've ever seen. It's been trained on just a staggering amount of text from books, websites, articles. I mean, way more than any person could read in 1,000 years. And all that reading has made it an expert at just one thing: guessing which word is most likely to come next.
Let's make that real for a second. You type "once upon a," and the model, based on all the millions of stories it's seen, calculates that the most probable next word is, of course, time. Okay, great. Then it takes that whole phrase, "once upon a time," and it asks again, what's next? Maybe there. Then was. It just keeps going, one word at a time, building out a whole response.
But here's the catch. To do any of this, the machine doesn't actually see words like we do. It sees something totally different. It sees the first secret piece of its toolkit, something called tokens. And this is where human language really starts to become machine language. So what in the world is a token? Well, think of it like the basic atom of text for an AI. Sometimes a token is a whole word, sure, but a lot of the time it's just a common piece of a word, like pre or ing, or maybe just a comma or a period. It's a super efficient way to work because it lets the model build and understand new words it's never even seen before, just by piecing together the parts it already knows.
And here's exactly what that looks like. To us, the sentence, "playing is fun," is what, 4 units? But to the machine, it's actually 5 different pieces. It sees play, then ing, then is, fun, and finally the period, each as its own little block. That's the language it's really speaking.
Okay, so the AI has broken our words down into tokens, but a computer can't really do anything with play or ing, it needs numbers. So the next step in this whole magic trick is to translate these tokens into the only language a computer truly gets, math. This translation process has a name. It's called embedding. Every single token gets turned into a long string of numbers, a vector. But, and this is the important part, these are not random numbers. This string of numbers actually represents the token's meaning and how it relates to all the other tokens. This is how the machine starts to get a handle on context.
And this is where it all kind of clicks. Inside the model's vast mathematical space, the number strings for words like cat and kitten are going to be really close to each other. They're related, right? But the numbers for cat and, say, volcano, they're going to be miles apart. For an AI, meaning is literally a measure of distance.
So we have numbers that represent meaning. That's a huge step. But what about grammar? What about the complicated ways words relate to each other in a sentence? This is where the real architectural magic comes in, something called the transformer, and its amazing attention mechanism.
Take a look at this sentence. The dog chased the ball because it was fast. Now just ask yourself, what does it refer to? Is it the dog or is it the ball? As humans, we know instantly, but for a computer, that's a really tough problem.
Well, the attention mechanism is what solves this puzzle. Instead of just reading word by word, it looks at the entire sentence all at once, and it weighs how important every single word is to every other word.
It calculates that, in this context, the word it is statistically way more connected to ball than to dock. It's not understanding, it's just incredibly advanced math that connects the dots correctly.
All right, so we've looked at all the different parts. The tokens, the number embeddings, the attention. Now let's put it all together. Let's watch the full assembly line in action, from the second you hit enter to that final answer popping up on your screen.
It's really a 6-step loop that happens in a flash. 1. You type your sentence. 2. It gets chopped up into tokens. 3. Those tokens are turned into numbers. 4. The model uses its attention to look at all those numbers and predict the single most likely next token. 5. That new token gets added to the end, and the whole process repeats itself again and again, generating one token at a time. And finally, 6. The full string of tokens is translated back into the words that you read.
So after seeing all the gears and levers behind the curtain, we get to the most important takeaway of all. This is about understanding what this incredible technology really is, and just as important, what it isn't.
Here's the bottom line. What is an LLM? It's an incredible pattern-matching engine. It is not a conscious or thinking mind. It's trained on a huge library of past data, which means it is not aware of things happening right now. It's a predictive tool, but it has absolutely no emotions or self-awareness. It's a mirror reflecting the data it was shown, not a person looking back at you.
And really, that's the best way to think about it. That feeling of understanding in conversation, it's an illusion, a brilliant illusion, created by an extremely sophisticated, highly trained, data-powered guessing machine. It isn't magic, it's math.
You know, understanding how the trick works doesn't ruin the magic. In fact, it gives you a new level of appreciation and, more importantly, control. You know now you aren't talking to a person. You're directing a powerful system that's built on patterns and prediction. So, now that you know the secret, what will you ask the machine?